Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 62 and difficulty it's been rated at is medium. This problem was asked by Facebook and let's just dive right in. So you've been given an n by m matrix of zeros and given n and m, we need to write a function to count the number of ways of starting at the top left corner and getting to the bottom right corner. The only operations that we're allowed to do are that we can move from right uh, or we can just move down. And you've been given an example over here. Unfortunately, the example is not that intuitive, but fortunately, we were able to find a similar problem on LeetCode, and the name of the problem is unique paths. Now, again, as usual, I would urge you to pause this video and check out the link given in the description below and try solving this problem on your own. The only difference between this particular problem and the problem, daily coding problem, is that you've been given a robot, and the robot is starting at the top left corner and needs to reach the bottom right corner. The dimensions of the grid are the same. You have a m into n grid, and the only operations that can perform that is that the robot can either move down or can move right. And obviously, you've been given a few sample notes over here that you can sort of go through. But what you want to do is you want to basically find out the maximum number of possible unique paths. And this is very easy to understand, to be very honest with you. And the reason why this is so easy is just because you can sort of visualize this as a dynamic programming problem. Again, whenever you have something like, hey, you have a grid and you want to count the number of ways, the approach should most likely be a recursive approach. But if it's such a simple problem like this one, you can think of maintaining a DP array or DP matrix rather, and just filling out the values as you sort of go about them. So one way of just understanding the unique path is that, hey, if this particular guy has already been reached, then you update the cells accordingly. What I mean to tell you is that if we have a robot over here, and just for the sake of argument, we have a 1D array, so what would happen is that there will be only one possible unique path. The path would be that, hey, this guy just needs to go to the right. That's pretty simple to understand. So it'll be 1, 1, 1, 1, 1, and 1 over here, which will be a finish line. And in the case of just having a matrix, which is a 3 into 1 matrix, the only operation that can perform is that it can just go down. And obviously, it cannot go right because there's nowhere to go over there. So it'll just go down in that scenario. And that will just be all ones as well. But what's more interesting to find out is that if we consider this particular guy, which in our dimensions would actually be equal to 1 comma 1, or you can just say belongs to row number 2 and column number 2. When we are over here, we can see for a fact that the number of ways to come to this particular point is that you can either go right and then down, or you could go down and then right. And what that sort of equates to is that you're basically adding the permutation at the topmost value or the number of possible paths that you've already computed at the top and at the leftmost cell. So if we have 2 over here and we know that this entire row is going to be filled with ones, and if we have 2 over here, if you want to look at this guy and just validate whatever we just came up with, we can see for a fact that if we add 2 plus 1, that will be equal to 3, and obviously the number of ways to achieve that is also 3. So number of unique paths to get to this particular element is 3. So you can go all right and then down, that's 1. Then you can go right, down, and then right, which is 2. And then you can go down and then all right, which is 3. So basically, in essence, the way you can sort of think about this is that the cell which is on the left hand side and the cell which is on the top hand side or top of the element, those things can obviously help us understand what's the number of unique paths which have already been generated. So that's the way we want to go about it. And again, the way we would sort of start off with is just by initializing a matrix. So let's just do that. We just say matrix, and I'm just going to use a quick list comprehension just so that we don't have to wait too much. So just write for underscore in range, and just fill up all the columns, and then also fill up all the rows. So all I'm doing over here is I'm just generating a matrix which has the dimensions m into n, and all the values which are there inside this particular matrix are zeros. Now, what we want to first do is we want to make sure that all the elements which are in the first row and all the elements which are there in the first column, all of them have a value of 1. So we'll just do that. We'll just say, hey, for I in range of m, all we want to do is we just want to update all those values, right? So we'll just say matrix I of 0, and this is just me updating all the basically all the elements which are in the first column and updating them to 1. And let me just cheat a little bit and copy paste this a little bit over here so that we can just write the same thing for the columns as well. So for all the columns which are in the first row, we update that as 1 as well. So let's just do a quick print so that we can see whether it's running fine up till now. And also we can see that the std out is printing out correctly. So you have 3 into 2 matrix, and you can see that the first row has 1s, and all the elements inside the first column are also 1. Now, our entire approaches are based on the fact that, as we're going about it, if you're on a particular cell, that particular cell, can be computed, or the number of unique parts to that cell can be computed by just going up or just going on the left. And that's very easy for us to do. We just need to do 2 quick for loops, and let's do that. We just say for I in range, and we're going to go from 1 to m. And the reason for that is just because you've already computed the values of 0, so you don't really want to go forward from there. So we'll just go from 1, 1. So same thing for all the columns as well. And now all you want to do is you just want to update the value of matrix and then move forward from there. The value of this particular element is just going to be something which has already been created. Basically, we want to go on our left side and on our top. So for top, we'll just do matrix I minus 1j, because that's pretty obvious, because I minus 1 will take us to an element on top. So if you're over here, I minus 1 would be this guy over here, and whatever's on this particular element, the value would be j minus 1. So we'll just do that. We'll just say matrix I and j minus 1. Oops. And that's basically it. So all you're doing over here is that you're just picking up this particular value and you're seeing, hey, what's on the top and what's on the left, and just add those 2 values up, because that will sort of help us understand what are the number of unique parts. And at the end, all we need to return is we just need to return the last values. So we just do -1 and -1. We also send in m minus 1 and n minus 1. That's your preference. But that's basically it. There's not much here to it. You just have a simple matrix which you've initialized, which has nothing but zeros. Then you've updated that matrix to make sure that all the rows, all the elements which are in the first row are updated to 1, and all the elements which are in the first column are also updated to 1. So once you have that, you know for a fact that whatever element that I'm now on, that can actually be computed by just going on the top or by going on the left. Because the only 2 operations that this particular robot can take is that it can either go down or it can go right. And that'll just help us compute all the values, and that's basically it. There's nothing more here to it. Whenever you have such a problem, you might want to make sure that you clarify a little bit more with the interviewer what he exactly wants. But let's just go ahead and run this code, and hopefully this should run fine. And awesome, you can see that the output is the same as the expected output, and let's just go ahead and submit this. And awesome, you can see that this particular solution is running faster than 75% of the Python online submissions. Not really important here. Just make sure that whenever you have such a problem, and we've gone through a similar problem before as well, but whenever you have something like, hey, you want to count the number of ways, this is most likely a dynamic programming problem. And whenever you have a DP matrix in front of you, and when you can represent it the way I have represented it, it makes a lot of things very, very easy for you. Cool. So if you had any comments, or if there's something that you do not understand, do leave it in the comment section below. I would love to handle any of your queries. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it. And have an awesome day. Thank you.